So I'm pretty sure after a whole long day of hacking conferences, we're all pretty tired after today. But fear not, we're underway. If you didn't get it, that's our joke. We worked for a whole hackathon just on that one joke. At the same time, we made a lot of fun on how so many of these bridges keep getting hacked. We all need bridges to be able to move our different tokens to the different chains, from Polygon to Ethereum itself, potentially even to Bitcoin. That's all could be possible through what we call Underwei. Underwei is an autonomous peer-to-peer public goods system that allows you to bridge your tokens to another chain without being required to rely on some of the core negative security that the standard bridges use. We are not minting tokens, we're not burning tokens, we are not creating new liquidity out of thin air. At the same time, we're not promising any APIs. There's only way to earn money through this is either being an AVS attester or through arbitrage. How do you arbitrage this? We'll go over that in a second through showing our front end and some of the tech behind. But it's purely, fully peer-to-peer. Through utilizing these bypasses, we can avoid these pitfalls and eventually become a bit closer to true decentralization of peer-to-peer trading and peer-to-peer bridging from chain A to chain B. Main reasons why these are important is censorship resistance is A. You work through a bridge, you work through someone else's contracts, you work through a specific amount of tokens from these people, and they could definitely cancel your token trade if they would want to. Obviously, this does not work with Ethereum or Bitcoin. This does work with USDC. Problem B is as well that, do you really trust some random people who build you a bridge? Do you really trust some people who by somehow manage to get a lot of liquidity on chain? We all heard in Solana a while ago how they literally gamified most of the liquidity through that, and we base our trust on some numbers that go up or down. It's way easier to trust a very simple contract that uses quite simple logic, which makes it, again, easier to defend. Less features, less complexity, easier to defend. Now, just a little bit of numbers. I think there's about 2.8 billion in money that got hacked through the various bridges. That's larger than some countries have in their treasury. That's larger than a lot of us will ever have. I think probably, well, some of you might. We know we have some smart people here. But it's a lot of money that just gets wasted through too bad security or just inefficient mechanisms. To talk with the tech, we're going to start with the basic Alice and Bob. Alice has 15,000 USDC on Ethereum, and in exchange, she wants to get Matic. Now, Bob has just a bunch of Matic laying around, and he sees through the front end that Alice is wanting to make a trade or wanting to do a swap. To dive a bit deeper into that, I'm going to start with the smart contracts and to explain a bit how those works. I'll let Evie take the word here.
All right, so on the smart contract side of things, we have chain A. A user deposits any token, and they can specify any other token that they wish to exchange on chain B. They deposit the tokens. This creates an auction struct, which contains all the relevant information about the auction. And then through the front end, a user notices the current price of the auction as it decays over time. Eventually, it becomes profitable for them to enter an acceptance offer on chain B. And now, importantly, at this point, that's a naive offer. And what I mean by that is that there's no direct communication so far. So you can either use the front end, or you can just check the smart contracts yourself. And so once that has been placed, we have a deposit on chain A, we have a deposit on chain B, and this second transaction triggers the AVS attesters. They get a task, they perform a task, and they're basically just checking that the auction is still valid, so that the funds are still on chain A, and the deposited token is correct for the deposited token amount. Once this is done, we use layer 0 to send a message between the different chains. And so we say on chain A that the buyer, we input the buyer's address, and we transfer them their tokens. And then on chain B, we have the seller's address, and we transfer them their tokens. And so it's a fairly simple system, but it guarantees that you can trade any token for any other token cross-chain. The Dutch auction incentivizing this to happen eventually as arbitrage is open. And to talk about the AVS testers, I'll pass it over to Alex.
Okay, so to attest the deal, we need an infrastructure to verify if the deal can happen and if the users are respecting the rules. So what happened is we built an AVS here, which is a decentralized infrastructure which gonna verify the tokens deposited on the chain A, the tokens deposited on the chain B, and every time, let's say Bob accepts the deal offered by Alice, it triggers a task on the AVS. The AVS is that part. And so there is a performer who's gonna be selected in a round-robin mechanism, and he's gonna verify if the transaction can happen. So what he's gonna do is basically it's just gonna fetch on-chain data on chain A and on chain B. He's gonna submit a proof of task and a result of that transaction to the network of attesters. So the performer submits the proof to the network of attesters, and if each attesters gonna verify if the task can really happen, because maybe the performer is a hacker. So they're gonna run the execution layers on their own. They're gonna verify the results with the results sent by the performer. And if more than 66% of the AVS network approve the transaction, it is sent with a smart contract called the AVS entry point smart contract. And then the transfer can happen on chain A and chain B. So it's what happens. And if the network, so if the attesters network doesn't validate the performer's task, there is two possibilities. Even the performer is a liar and he wants to hack the system. So in that case, the distributed network gonna realize it, and it's gonna punish the liar performer by slashing him with the eigenlayer smart contract, the slasher smart contract. Yeah, and that's it for the AVS part.
I'm going to quickly show you some of the front end we've developed. This front end is currently online. The contracts have been developed and are also deployed to the, oh, there's no internet here for me yet. Yeah, I have 1 second. Technical issues, have you heard about those? It's gonna go quicker because I'm already having the... Yeah, we came straight after the hackathon here. I don't know if you know Brussels, but Wi-Fi problem is apparently a thing. Just to make a short introduction on how the simple system is supposed to work, you start by putting in the right token and the amount you want to get back. Here you get an initial recommendation rate. It's very important to mention we do not use any oracles. This is a coin or coin market or any kind of API where we pull a recommendation. We really need to avoid oracles to be able to guarantee maximum security. Under this, you have a slider where you can choose how long you are willing to go over which certain time period. So let's say you're willing to go down with about 500 USD in 4.2 days roughly. That means every second or every block confirmation, your tick rate is going down. If you're in a big hurry, you want to be able to push this out as quick as possible. Maybe you have some kind of a cross-chain opportunity and you're willing to give away 20% of your total value because you can cross-chain arbitrage it and be able to get a 50% more there. As long as the ROI for people makes sense, they are able to go down and are able to decrease the amount of time frame, which means the quicker it's going to go down, and increase it longer in case they want to have it longer. It's important to notice we start with an initial 7 days maximum that we try to recommend people. Again, to not incentivize have any large liquidity being stored in our contract, which would make it a bigger risk for potential attackers. On the right side is a front end, which everyone can see. As you see, we're not even connected here. Everyone can notice which are the currently open arbitrage trades, which could make you just do a quick swap yourself and allow you to potentially earn an easy $100 or $50. As long as the gas is cheaper on the chain on which you are going to communicate with, you are more than likely to be able to make a quick arbitrage opportunity. Free money. The only thing here is that this is purely front-end based, but it doesn't need to stay that way. All our contracts are open source, they're all deployed, all our code is open source. In the end, you can just hit up your own bot that runs on chain and automatically start picking up arbitrage opportunities, which is only better for the security of the overall system, as the quicker the money leaves our system, the harder it is for hackers to try to get a large enough attack or enough resources to be able to try to claim it. Thank you for giving your attention to us for a couple of moments in these busy days. We were not just the three of us. Some of us did not want to be on stage today, but they're around you. You'll see them when you see them. And thank you to Authentic for giving us the opportunity to be here.